Northern Minnesota is extremely desolate. For over 100 miles, there's not a single area with over 10,000 people. Recently, Janet and I received a call from the Ancient Artifact Preservation Society about a large stone some would call a menhir, located in the Arrowhead region of northeast Minnesota, really close to the Canadian border. The question is, was this stone man-made, or was it formed by a massive geological changes in the area much farther back? The answer to that, you will soon find out. We are here in about 2 miles off the Gunflint Trail, near the end of the Gunflint Trail in extreme northern Minnesota. In fact, the Canadian border, which is probably just this direction, is within hiking distance. And we're here at a gigantic standing stone called the Menhir. And the big question here that people want to know is this man-made? And if so, it would be possibly the largest man-erected standing stone in the world. Or is it natural? So I'm going to try to answer that question with my initial impression. And that is, if you look over here, Jan, you see this huge block?
Yep.
That's probably 8 feet thick at the most. And it's a large block, probably 20 feet across, at least 15 wide by 8 feet thick. And it's laying roughly horizontal, which is what the natural rock is, laying horizontal at this location, roughly horizontal. And there's a slight undulation to the sediments here. But here we have this thing that's lying perpendicular. The sediments should be like this, but this thing's standing like this.
Right, 90
How did
degrees.
that happen? Well, what appears to be the case here is a large block, a much larger block than that one right there, was tipped up, most likely by the glaciers. And what we see here with all these large flat pieces is this much fatter, thicker stone that's standing up here, was fatter at one time, and slowly but surely, because of weathering and freeze thaw, wetting and drying, pieces are spalling off and it's getting thinner and thinner. That's why we see these big slabs laying here and on the other side. So right now, if I had to put my money down, I'd say it's natural.
I would agree. So Scott, how did this standing stone, which is massive, end up so perfectly standing upright?
Where the sediments are perfectly perpendicular to the ground. I think I can answer that. We're standing next to a massive block of the same stone right here that has been dislodged from the bedrock and probably pushed over here from not too far away. The same was true with this big block. Now, if you can imagine a dice, right? Every time you roll the dice, it's always going to land on one of those sides, right?
Right.
So essentially, this big block is either going to land on one of these flat surfaces, and in this case, this obviously much larger, thicker block that is now a lot thinner because of spalling off of the different layers. When it landed on a flat side that happened to be perpendicular to the ground rather than parallel like this one. And over time, that perpendicular block, which was much thicker, has thinned through spalling on both sides. That's what all this debris is here. All these big layers of rock, these slabs, came off this side, and we have another pile of rocks on the other side. So I think that's what happened. This great big dice of rock just happened to land with the sedimentary beds upright.
So why do these pieces look like they fall out so perfectly straight, like they're almost carved?
That's because the sediments. This is a very old sediment, billions of years old. It has weak planes in it. Water gets in, it freezes, and it spalls along those planes, and it splits just perfectly into these nice slabs. If you look, I mean, even this piece here, that big slab, which is, I mean, that one right there is close to 10 feet thick.
Yeah.
That one probably was up on here too. And the other thing is, it may have been wider at the base and kind of went like this. So it had like a big, kind of a fat bottom. That's how it landed. And now it's all spalled off.
So talk to us about why it's magnetic and how can you know that?
Well, it's magnetic because it contains magnetite. And
What do you have there?
what's interesting here is this compass is basically worthless up here because of all the iron formation and the magnetite. And you can watch and see what happens when I touch it on the stone. Now we'll do another spot and it ends up somewhere different. So
And what about the standing stone itself?
the whole thing, it's all
Because-
full of magnetite.
Because this rock here that you were just doing that to came off
Yeah.
this Menhir Stone, this giant
Yep,
standing
this is
stone.
a piece that spalled off of this side. And all these rocks right here came off this side. So this was a much bigger block at one time and probably was closer to being a big cube than a big, tall, thin slab like it is now. The weathering and the spalling of these great big sheets that came off of both sides are why it's so thin now. It looks like it's man-made, but I'm pretty sure that it's not.
How long ago did that happen? That it was put here, do you think?
Well,
By
it
the
was
glacier?
deposited by the glaciers about probably up in this area 10 to 12,000 years ago. And so in that time, all this rock has weathered off, creating this beautiful, thin monolith.
Go ahead.
Say action.
Action.
2, 3, 4, 5, 5.5. 5 times 6, which is my stride, is 30 feet. Plus a little bit more is about 33 feet. And I was told that the Menhir is about 33 feet tall. So imagine this huge block right here. And if you look over the edge, we see at least an edge right here that's 10 feet, maybe more. So imagine this huge block that if we stood it on end would be the same height as this stone here. And over time, if this was upright, which this one was in the past, eventually it would spall off and all those big slabs we see on both sides of the standing stone, the same thing would have happened to this rock. So I think this big block right here to me is some of the most compelling supporting evidence that nature put this in that position on a large flat surface like this, except it was upright and then it spalled to create the Menhir.
So what do we have here?
Well, we're trying to explain how this giant monolith, the Menhir, was able to be transported and tilted up naturally. That's the argument that we're trying to make.
Right.
And right here is something very important, glacial striations. Do you see them?
Yes. And they run differently than the direction the rock fractures, which is what these cracks are.
Right.
So,
So-
it's different. It's just the surface, right?
Yep. So we are at high noon right now, and it is past the equinox, so our shadows are being cast to the north. So the north is this way, which is where the glaciers came from and traveled to the south. So this ice flow direction, roughly north-south, makes sense.
Okay.
And this rock right here is the exact same geology as the Menhir.
Right.
So I would like to move over to that block there that's about 100 feet away and talk about how the Menhir, where the Menhir came from. And now we know the direction the ice came, so it had to have come from the north and
Right.
be deposited south, right?
And this is a big cliff face of rock that is still bedrock, that is still in place,
Right.
in situ.
And the bedding planes are running roughly horizontal.
Right.
So how did they get like this is the question?
Yes.
We'll answer it.
All right.
Got it.